The next objective is to use a confidence interval to draw a conclusion for a two-sided test about a population proportion. So using the test that we just did, and if you haven't watched this video, if it's been a couple days since you watched this video, you might pause here and reread the scenario just to get caught up to speed. But essentially what's happening is Yan Hong wants to test if the proportion of students at her school who say they have never smoked is 68%. So she runs the test, and we got a conclusion where we rejected the null because we had convincing evidence that the proportion of all students at the school who say they have never smoked is different from 68%. So this was a two-sided test. And so the goal is to make this connection between the two-sided test and a confidence interval, because they give similar information. And the way I want you to think about this is, imagine instead of running a test, we created a confidence interval. So we have her p hat plus or minus the margin of error. So her sample was that 90 out of 150 say they have never smoked. 90 out of 150 is 60%. So you can see that's different from 68. So if we were to use this to create a confidence interval, let's say we wanted to have 95% confidence interval. That means we would have, it's for a population proportion. So it's a Z, and the critical value would be 1.96. We'll take the point estimate plus or minus critical value times the standard error using the sample proportion. And if we crunch these numbers, we'll get a confidence interval of 0.5216 to 0.6784. We had a margin of error of 0.0784. So if you think about the interpretation of this confidence interval, what we're saying is we're 95% confident that the proportion who claim to have never smoked is between 52.16% up to 67.84%. Her test was against the null being 68%. So since 68% doesn't fall within this interval, if we were using this confidence interval to determine whether the proportion who's claimed they haven't smoked was 68%, then we have reason to believe that it's not true. It's not 68%. We are 95% confident it's less than 68% because this is what our interval, the information that our interval is providing. So you can see that a significance test about a proportion and a two-sided test, it's really important though that it's a two-sided test, relates to a confidence interval. A 95% confidence interval gives approximate null hypotheses that should not be rejected. So in this case, if the null hypothesis was anywhere between these two values, then we would not reject. We would have reason to believe, or we wouldn't have evidence to believe that it's not true. But since 68 doesn't fall within this interval, we have reason to believe that 68 is not true. So we reject any values, any null hypotheses that fall outside, but we would fail to reject if the null hypothesis fell within the interval. A two-sided test at a significance level of alpha, and I'll explain this in a second. A confidence interval, so a 95% confidence interval relates to an alpha level, a two-sided test at an alpha level of 5. They give similar information about the population parameter. For example, if you think about how a confidence interval is computed, when you find your critical value for a 95% confidence interval, there is 95% centralized and another 2.5% here and a 2.5% here. So that's why a 95% confidence interval relates to a significance level of 5%, because there's 2.5% here and 2.5% here, which totals the 5%. And the equation to figure out the level of confidence that relates to a significance level, you multiply 100 times 1 minus the alpha level. For example, I'll show you here. If we had an alpha level of 10% instead of 5, then 1 minus the 10% leaves us with 90% times 100 gives us 90% confidence interval. So a 90% confidence interval relates to a significance test at a 10% alpha level. And then the last one that we'll look at is a 99% confidence interval relates to a 1% alpha level. And you can see that again just by following the formula. So bottom line is, If the null hypothesis falls within your confidence interval, then you'll fail to reject because it's a plausible option. But if it falls outside of your interval, then you would reject the null because you have reason to believe it's not. You have reason to believe that it's not the null because it doesn't fall within the values that you believe are plausible.